Hello, my name is Alberto Bravo. I am the product owner of Trento at SUSE, and I am very happy to be here at SUSECON to talk to you about SUSE's latest solution supporting SAP applications. I will start with a brief introduction of Trento, where I will cover what Trento is, what its main features are, and what its delivery model looks like. I will then continue with a demo that will be based in two different use cases: a cluster failover and a wrong cluster configuration. Trento is an open cloud-native web console that aims to help SAP basis resources to monitor the entire operating system stack of the SAP environment, including high availability components when they are present. The screenshot in this slide shows the web console homepage or dashboard, where SAP basis admins can determine at a glance the global health status of their SAP systems. Trento is powered by event-driven technology, what allows the web console to react in real time to changes happening in the backend environment. The Trento web console is modern, clean, and intuitive, and it has been designed with the needs of an SAP basis admin in mind. The screenshot in this slide shows the SAP Systems view, where SAP basis admins can see the list of discovered SAP systems and their corresponding databases. Custom tags can be created across the Trento web console, which, combined with the capability to filter by tags, comes very handy in large SAP environments. Trento provides automated discovery of SAP systems, SAP instances, and SAP HANA clusters. In the SAP Systems view of the Trento web console, you can expand each listed SAP system and display the instances that are part of it, both in the application layer and the database layer. The system in the screenshot, for example, has 4 ABAP instances and a clustered HANA database. Trento can validate the configuration of SAP HANA Scale-Up performance-optimized clusters deployed on Azure, AWS, or GCP against SUSE best practices or specific recommendations from different vendors. When Trento detects a configuration that deviates from such best practices or recommendations, a yellow or red result is issued depending on how critical that piece of configuration is for the cluster operation. Trento integrates with Grafana and Prometheus to provide graphic dashboards about CPU and memory utilization in each discovered host. We can also enable email alerting for critical events happening in the monitored landscape. For example, when the heartbeat of a host fails or the health of a component goes critical. This feature raises the awareness of the SAP basis admin even when they are not working on the console. Trento has two main components, the server and the agent, with different delivery mechanisms. While the agent is available as an RPM package in the repositories of /for-SAP 15, SP1 and higher, the server is delivered as a set of container images from SUSE registry together with a Helm chart that facilitates the installation. Trento is supported on any cloud-native Computer Foundation certified Kubernetes distribution. And now, after this brief introduction of Trento, it is time for our demo. We are going to start with a failover use case scenario. In this use case, we are going to force a failover in a cluster that is running fine and see how the Trento console captures the event. In the dashboard of my demo environment, we have system NWD with all components in passing status. In the SAP Systems view, we can see that the primary instance is running on node 01, that the secondary instance is running on node 02, and that the replication between them is in active status. The cluster details view confirms that all running indicators seem to be fine for this cluster at the moment. Let me go back to the dashboard because I want to start monitoring the reaction from there. In Node 01, I am going to switch to the HANA admin user and kill the database. In Node 02, I am going to monitor the status of the cluster at OS level. Back to the Trento console, we notice that the status of both the database and the SAP instances has gone gray. This means that at least one instance is stopped or in unknown status. Let's figure out which one. First, I click on the System ID link. The SAP System Details view shows that all ABAP instances are running properly. Let's have a look at the database instance. The HANA Database Details view shows that, indeed, the instance in Node 01 is now stopped. But this database is managed by a pacemaker cluster. Let's see what the corresponding cluster details view has to say about this situation. It might take a few seconds for the information in the cluster details view to be updated, but eventually I will see that the health status is now 1, the sync state is as failed, the instance in Node 01 is in failed state, and the instance in Node 02 has now a primary role. This is a clear indication that a failover has happened. Back to the console dashboard, I see that the pacemaker cluster for system NWD has turned red. And now it's time for the basis admin to investigate what has happened with the instance in Node 01, bring it back when possible, and restore the cluster to a healthy state. Let's move now to our second use case in this demo. In this use case, we are going to use Trento to determine why the HANA cluster of an SAP system is in critical status, and to learn about the necessary actions to fix the situation. In the dashboard of the Trento console, I can see that the cluster of system NWQ is in critical status. Let's go to the corresponding pacemaker cluster detail view to figure out why. All runtime indicators for this cluster seem to be fine, with the primary instance running on Node 01, the secondary one running on Node 02, and replication in SOK status. It must be then a configuration issue. Let's go and review the check execution results. And indeed, I can see that the result of the check for the corosync token timeout is critical. I make a note of the check ID and look for it in the checks catalog. This environment is running on Azure. Therefore, first I need to select the right environment on top. The failing check is the first one on the list. I click on it. Trento tells me that the token timeout should be set to 30,000 in Azure, and that the solution to fix the problem is to edit the corosync configuration file in both nodes, set the right value and reload the corosync configuration. The corosync configuration file is located under /etc/corosync. Let's go ahead and correct the value of this parameter in both nodes of the cluster. Back to the Trento console, I will trigger a check execution to see if the change took effect. I wait a few seconds for the execution to complete. And now the check returns as passing. Back to the console dashboard, the cluster health status also shows now as passing. And this concludes this brief introduction and demo about Trento. I hope you enjoyed it. If you have general questions about Trento, please visit suse.com/Trento. If you would like to know how to get started with Trento, please have a look at our article in the SUSE documentation site. Or you can send us an email to trento-project@suse.com and we will be more than happy to help you get on board. Thank you for attending, enjoy the rest of SUSECON, and have a good day.